I welcome to this session. Today we go to see Maxima and Minima. To find the extremum value. So the extremum value is nothing but lower value and upper value that we call as maxima and minima of a function. So let us consider any function f of x comma y. So now we go to what are the steps involving for the finding maxima minima. Step 1. So first you go to differentiating the given function f with respect to x. So it is generated by dou f by dou x. Similarly the same function f you go to differentiating with respect to y. So we get dou f by dou y. So let the notation a is nothing but f double x. F double x is nothing but the function f. So already you differentiated once, we get fx. The same function again you go to differentiating with respect to x, we will get f double x. So generally we can write in the form dou square f by dou x square. B is equal to fxy. So already you go to differentiating the function fx. Again with respect to y, we will get fxy. So it is generated by dou square f divided by dou x dou y. Then c is equal to f double y. So differentiating the function f with respect to y twice, we will get dou square f by dou y square. Then step 2, stationary points. Find the stationary points by solving fx equal to 0. So already we know the value of fx. We can equating 0 and fy we can equating 0. So we will get a stationary point. Next step 3. So we want to write points a, c, b. We want to calculate az minus b square. Finally we will give the conclusions. So we will get a point a comma b. So already we solved fx and fy in equation step number 2. So we will get a stationary points. The first point we taken as f of a comma b. So suppose replace a comma b, we will get a is negative and ac minus b square is positive. So we will give the conclusion that particular point a comma b is a maximum point. So the same a, suppose if a comma b is positive and ac minus b square also positive, so we will conclude that it's the particular point is minimum point. Suppose let us consider any point a comma b. So ac minus b square is negative, so we call as a saddle point. So let us consider the point a comma b. So if it is equal to 0, we will tell inconclusive. That means we cannot say either maxima or minimum or saddle point. Further investigation should be there. Next step 4. So maximum minimum values. So find the maximum and minimum values using the identity point a comma b by substituting in f of x comma y. So in step 3, so we know the value at which point it is maximum and which point it is minimum. So in that we can replace the maximum point in that f of x comma y, we will get maximum value. We can replace the minimum point in the f of x comma y, we will get a minimum value. So we know that one which is extreme point and extreme values we can find by these steps. Problem number 1. So examine f of x comma y is equal to x cube plus y cube minus 12xy minus 30y plus 20 for its extremum value. So instead of maximum and minima, so indirectly they are giving the extremum values. So therefore given f of x comma y is equal to x cube plus y cube minus 12x minus 3y plus 20. Let us taken as f of x comma y. We need to find step on fx. Differentiating the function f with respect to x, we will get, so differentiation of x cube is 3x square. Differentiation of y cube is 0. Why? Because we are differentiating with respect to x. Therefore y cube is a constant term. So minus 12x. Differentiation of 12x is 12. So minus 3y. 3 and y both are constant term. Differentiation of constant term is 0. Again differentiation of 20 is also 0. Similarly we go to differentiating the function f of x comma y with respect to y, we will get fy. Then we need to find a. So differentiating twice the function f, we will get a. So differentiate the function f with respect to x and y, we will get b. And differentiating the function f with respect to y twice, we will get c. So now stationary point we need to calculate it. Therefore we can replace fx is equal to 0 and fy equal to 0. So therefore fx is 3x square minus 12. So equating 0. From this we can get a x value. So x square is equal to 4. Therefore x is equal to plus or minus 2. Similarly fy is equal to 0. Therefore 3y square minus 3 equal to 0. Therefore from this we can find y is equal to plus or minus 1. Therefore the stationary points are 2, 1, 2, minus 1, minus 2, 1 and minus 2, minus 1. So the stationary points A is nothing but 6x, C is equal to 6y, B is equal to 0. So AC minus B square, we need to give the conclusions. So replace x values, x is equal to 2, y is equal to 1. So A is positive and AC minus B square also positive. Therefore this is a minimum point. So 2, minus 1, therefore A is positive and AC minus B square is negative. Therefore it is saddle point. Minus 2, n, A is negative and AC minus B square is positive, therefore negative we will get, it is also saddle point. So minus 2, minus 1, therefore AX is negative and AC minus B square is positive, therefore it is a maximum point. So therefore from this we know that one maximum point is minus 2, minus 1, minimum point is 2, 1. Therefore we need to find the maximum and minimum value. So therefore f of x, y is equal to this, the maximum point is 2, 1. So therefore minimum point is 2, 1, replace x is equal to 2, y is equal to 1, we will get f of 2, 1 is equal to 8. Similarly the maximum value 2. So the maximum point we need to find, the maximum point is minus 2, minus 1, therefore maximum value is replace x is equal to minus 2, y is equal to minus 1. So we will get the maximum value is 38. So next problem, discuss the maxima and minima for the function f of x, y is equal to x cube plus 3y plus y cube minus 3axy. Given f of x, y is equal to x cube plus y cube minus 3xy. So we need to find fx, fy, so a, b, c. So from this we need to find stationary points. Equating fx and fy is equal to 0. So equating fx equal to 0 will get x square is equal to ay. Equating y square is equal to ay. Therefore x square is equal to ay, substituting y square is equal to x, we will get x power 4 is equal to this. From this we will conclude that x is equal to 0 or x cube minus a cube is equal to 0. Therefore x cube is equal to a. Similarly x is equal to a, 0 or a. So therefore x square is equal to ay. So x is equal to 0 means y is equal to 0. X is equal to a means y is equal to a. Therefore the stationary points are 0, 0 and a. So therefore replace the value. So we will get a is 0. Therefore saddle point a. Therefore it is a minimum or maximum. Therefore at a, we will give that if f has maximum, if f has minimum. So therefore of a, is minus a cube. Next problem. A flat circular plate is heated so that the temperature at any point x, y is given by u of x, y. So that is equal to x square plus 2y minus x. Find the coldest point on the plate. So heated temperature, therefore we need to find the coldest means minimum temperature. So the minimum only we need to find. So given u of x, y is given. So f of x is u of x, y. We need to find fx, fy, a, b, c. So from this we need to find the stationary point. Fx, equating fx and fy is 0. So equating fx equal to 0, we will get x is equal to 1 by 2. Equating y is equal to, for fy is equal to 0, we will get y is equal to 0. Therefore the stationary points are 1 by 2, 0. Therefore we can replace x is equal to 1 by 2 and y is equal to 0. We will get a is positive and ac minus b square is positive. It is a minimum point. Therefore at 1, 2, 1 by 2, 0 is the minimum point. Therefore a is equal to 2, that is greater than 0. Therefore ac minus b square is equal to 8. Therefore it is also equal to 0. F has the minimum point. So the minimum value we can replace 1 by 2, 0. Therefore we can replace the value. So we will get the 1 by 4, the coldest point on